So following on from the previous video, we were trying to sketch this graph here, okay, and we got to this stage here, where if we head towards -7 from the right hand side, it will head towards negative infinity, and then as you head towards -7 from the left hand side, it will head towards positive infinity. Okay, so this is a stage that we got to in the last video. So now we are now going to consider what happens when x is very very large. So when x is very very big over here, and when x is very very big but negatively big on this side here. So we're going to consider what happens when x is positive infinity and negative infinity. Okay, so let's look at this now and put a very very big number into here. So we're going to see what happens around this region here, where x is very very big. So let's put something very very big in here. So let's put 99999. Basically put a very very big number into here and into here. So let's put this here. So yeah. So we're gonna put we're gonna put this number, a very very big number, in fact a very very big number, put this very very big number into here. So this will become +5, so that will become this +5. Okay, and then put that same big number into here. Okay, so we are going to put 999 whatever. I don't know if it's going to be the right amount, but we're going to put this same number into here now, and then when we +7, it will become this. Okay, so we've got this number here divided by this number here. The point is that these two numbers are, well, if you get a calculator and I'm punching, well, I don't know if you can punch into this. I don't know if you can punch this number into your calculator, but this number here, when you get a very very big number that differs by a slight amount, a very very big number that differs by a small amount, it will be approximately be 1. The point I'm making here is that when you put a very very big number into here, even though you add 5, and then you down here you add 7, well, because this number here is very very big, this 5 here is next to nothing. It's just irrelevant. If you put a very very big number into here, even though you're adding 5, it's really irrelevant. Because if you put 99999, a very 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 big number here, and then you add an irrelevant amount in here, yes, it is slightly bigger, but it's nothing in comparison to this whole thing here. The point is that this, well, when x is very big, this thing here will be approximately be 1. Because if you put a very big number here, you can pretty much ignore these two numbers will be irrelevant. It will be a different case when you put a small number in here. So let's say if you put the number 1 here, and then put the number 1 into here, you see 1 plus 5. Now this here is relevant. In fact, it's more important than this 1 here. And then down here you put 1 into the x here, and then you plus 7 here. You see this 7 here is very important. Well, it's a lot bigger than, it's a lot more significant than this one here. But the thing is, when you start to put a very very big number, into here, and then a very very big number into here, these two numbers here are irrelevant. In fact, let's make it to the power of 999 as well, to the power of 999 here. These numbers will be next to nothing. So as x, well, the trick that we normally use is this here. You can visualize it like this. Okay, so you've got this thing divided by this thing here. The trick that we normally use is visualize it as a one bubble here, visualize it as one bubble here. Divide top and bottom here by x. Okay, divide top and bottom here by x here. So so this top part here will be x over x plus 5 over x. So when you divide the top bubble here, x plus 5 divided by x here, we are just considering this bit here only. Okay, and then down here you've got x plus 7 over x here. You can break these. You can break this up here into this and into this. Okay, and then for the bottom part you will have this x over x plus 7 over x. This is just a trick that we use to find out what happens when x gets really big. Now this here becomes 1. Okay, 1. This bit here, x divided by x will become 1, and then plus 5 over x and 5 over x, and then at the bottom this thing here will become 1, and then plus 7 over x. Okay, so we are just translating this thing here into this thing here. Okay, but then now looking at this here, as x tends to hang on, let me clear this. As x tends to infinity, this number, as x tends to infinity, this number here will be very big. So you've got 1 plus 5 over 99999999999 divided by, and then this one here, 1 plus 7 divided by 9999, a very big number. And then 5 divided by a very big number is next to nothing. You can consider as 0. This thing here will be 0. So overall it will be 1. So as x tends towards infinity, it will head towards let's say 1 is here. Hang on. Let's say 1 is somewhere here. 1. So as x tends to infinity, this here tends to 1. So it will be something like this. Okay. So the trick that we normally use here is to divide, to visualize it as one bubble here, divide top and bottom here by x. This is just a trick we would use to evaluate it as x tends to infinity. So you will have this. This thing then becomes x over x plus 5 over x over x over x plus 7 over x here. This thing here is 1. Okay, so this thing here is 1. This thing here is also 1. And then if you think about it, as x tends to infinity, this number, the denominator, will be very big. So you've got 5 divided by something very big, which will be 0. Which will be 0 here. The same argument can be used down here. So put something very big in here, then that would be, this whole thing will be 0. So you've got 1 over 1, which is 1. Okay, so this thing here tends towards 1 here, and then you can use the same argument over on this side as well. And now divide. So on this side here, divide top and bottom by x. So you have this x over x plus 5 over x, and then the denominator x over x plus 7 over x. This thing here becomes 1. This thing here becomes 1. Will become 1. So now if you put a negative big number into here, let's say 9 minus 9999999 into here. Okay, let's do it. Let's put minus 9999 into a very big number into here. You can move the minus up here. Okay, and then you can move the minus out here. So basically it becomes minus this thing here. You see, this whole thing here, 5 divided by a very big number, it will be what you can consider as to be 0. So you've got 1 minus 0, which will remain at 1. So this thing here will head towards, well, even if you put a minus 999 into here, the minus gets moved out here, and then you've got minus a well. Yes, even though it's a minus number, you're going to minus 0. So overall, this whole thing here will be 1 over 1. Okay, so the same argument can be used in the negative realm as well. So it will head towards 1 here. So this is 1 here. So this thing here will head towards 1 here. And the other point that you can do is you can always put 0 into the x here. So you can always find the intercept. The intercept in this case happens to be, well, when you put 0 into here and 0 into here, it will be 5/7. So we know that this here is 1 to be round here. The intercept will be 5/7. So we know it's going to do something like this, and then it will head towards 1 here, and then on this side here it will do something like this. We're not done yet. There's something else we have to consider. So far we know the intercept to be 5/7. Hang on, let's say this here is 1. 5/7, 5/7 here. So we know it's going to do something like this. Okay, but we're not sure yet. Hang on, we know it might be. We know this at the moment. Hang on, we know this at the moment. It's heading towards 1 here. Okay, but so this is what we know so far. Okay, yeah, this is what we know so far.